So good evening, everyone. So I'll share my screen. I'll show you the topics what we are going to discuss today. Since students they requested for VRF, so we will do a VRF lab today. And apart from that, we are doing one more BGP discovery lab. So we are using a route reflector for it. So let me start this. Uh, Let me fire up this lab. Okay, so what we are going to achieve on this topology, I'll give a glimpse and then we'll jump into the practical right away. So I would say this is most of the engineers even they have 10 to 12 layers of experience and they are implementing this BGP. Then I found this is a kind of a difficulty. I would say the people they struggle to do this because here we are going to look about exactly the complete interworking of IBGP and EBGP and how do I use that and how the route reflector helps. And also we'll go through what is the use of next hop self and also we'll see how this EBGP neighborship happens. We did this in the lab, but this discovery lab is something we are using a multi-hop attribute for EBGP neighborship. It should be directly connected. Example, if you see this is over here is AS2 and the router 3 this is on AS1, so we are making a neighborship between R3 and R5 as well as R1 and R5, but R3 and R1 they are on AS1. If you see this is IBGP AS1 and this is on AS2. So when we make a neighborship, what happens here if I make a neighborship from, if you look at this two links that's running between R3 and R5, Ethernet 0/1 and fast Ethernet 0/4. That's a point-to-point connection, whereas I configured 50.0.0.1 over here and dot two on the point-to-point on R5. But for this is a directly connected. You can establish a EBGP neighborship. Whereas what about this router ID 3? So we are using the loopback interface for it, right? So if you calculate the number of hops from R5 to reach the loopback address, that's actually in a different subnet, so it has to go through 50 network and then it should hop back to the loopback interface. So when you're making a EBGP between R3 and R5, you have to use a EBGP multi-hop because as per the, I mean, the criteria of EBGP neighborship is both should be directly connected. Whereas, but if you look at this 50.0.0.2 on R5, and this is configured on the physical interface that doesn't have, that doesn't have a direct connection to the loopback address. So to resolve this, we are going to use a EBGP multi-hop. So apparently this is a two hop away. Since we discussed about all this, hops and TTL, so we are very familiar with that. So in the security standpoint, if you want to implement something like this, you can also use a TTL security. Example, if you give TTL security of 2, if there is a loopback that's hanging off on the R2, if it is trying to establish a connection, it's not going to happen because if you calculate the TTL of 2 is for 2 hops from R5 to reach router ID 3, that is loop back on R3. But whereas if I want to reach R2 and the loopback interface 2.2.2.2, I have to go through multiple hops. I mean, if you calculate, it's more than 2 hops. If you calculate this from R5 to R2, there is more than 2 hops. If I make a TTL security of 2 right over here, then it is a problem for the R2 to reach here because I'm limiting my R5 to just the TTL value of 2. So you cannot make I know you cannot establish a neighborship with someone who has TTL more than 2. If the hop count is more than 2, you cannot make a neighborship. So let me quickly take my pen to just explain you very quickly about that. I think there is a glitch. Okay, so what I'm trying to say here, for if you look at this, this is of TTL of uh, so from R5 to this guy, between these two links, right? So between the 50 network, this is TTL of 1. But if I want to reach the router ID 3 loop back, so it should be TTL of 2. So what I'm trying is, if I'm trying to limit my router with a TTL security of 2, if this guy over here, R2, if he's trying to establish a connection here, it's not going to work because I'm limiting my TTL to 2. But this is an use case I'm telling you. But what we are going to achieve in this lab is, we are going to do an EBGP multi-hop, and it should be directly connected. That's a condition of it, right? It should be directly connected. But if you actually see this router ID 3.3.3, this is not directly connected. So I have to go through this actual physical link to reach this loopback interface. So this is not directly connected for R5. So how we are going to solve this problem? We are using the EBGP multi-hop, and I'll tell you in which uses. I mean, in which particular scenario this is very helpful. This is only applicable for EBGP neighborship. Example, if I want to give an use case here, so let's take this is an ISP here, the router 5. This guy is an ISP, and these two are the customers routers called customer edge C router, and this is a provider edge, is a P router, and you make a BGP, you make an EBGP. Yep. For the public routable address, you have to use an EBGP. You cannot use an IBGP. So you're trying to establish an EBGP connection here. But if this provider has to make a connection to your loopback interface, if that is a use case, if you want to make your neighborship with the loopback, because if my actual connection goes down, still I have a redundant connection. If I take a different color, that stands out. So okay. So if you look at this, the blue lines following here, so I have one more connection like this, right? So I can go to R3 over R1, I can reach R3. So if I make the loop back, if I make use of a loop back, even though if I lose a connection to this, I can still reach to this guy over router ID 3.3.3.3. So in this case, if the if the provider is they are trying to establish a connection like this and they want to use an loopback interface, apparently you have to use an EBGP. It's a vice versa process. If you look at this, even in the EBGP on the this is a provider edge, and if you want to make a peering over your loopback address, you can still use this with the EBGP multi-hop. So that's why that is what we are trying to achieve here. So what if here? So coming back to this route reflector. So this guy over here, the R4. So we made an IBGP. So what is the condition of IBGP? So why do we use an IBGP? We know that and we did that. So we use the local preference here, right? So if this is a transit router, this is my transit point for R1. So you guys know about transit point, right? So my traffic is, you are intended and you are designing your network, and for that your actual traffic should always go to this transit point. Let me take a different color. That should stand out. Okay. So this guy over here, his transit point, right? So it's for to reach R2, even for R3, that if the transit point is R4, if I say transit point, even though this device is directly connected and it is just one hop away, but if I made this as a transit point, this can be my core switch, right? This is how you design, and it can be your hub. In any case, if you make this as a transit point, so all my router has to go through this particular router to the other devices. You have a design as such, like your DMVPN. So when you are deal with those design principles, we use the local preference, right? We use the local preference. So what we did, so we advertised the highest local preference, and this is only applicable for IBGP. So the router with the highest local preference is preferred, and we are doing this is per neighbor relationship. So this guy is going to advertise this. The local preference is 200. So by default, all the other link has a local preference of 100, and this is purely based on the AS number, right? So for all the AS1, the local preference is 200, and this guy over here R4 is advertising this local preference 200 for all the devices. So for all the rest, I mean, all the other links, the local preference is 100. So apparently my transit point becomes an R4. That's what we achieved in the last lab. So here there is a use case. So they are telling that, okay, you have to come up with a plan. So it's a pain. I mean, I got one transit router, and I want to establish multiple routers. Example, if you use your SD-WAN, right? This is your SD-WAN hub device, and this is all your spoke devices. What if you got, example, you got 30 spoke devices? The spoke, this is your spoke. So what if you have 30 spoke devices? So you cannot do a IBGP. So as I said, for the IBGP, what is the criteria? You should have a route to it. For all the devices, you have to have a route, and you can use your loopback interface, because the basic criteria of IBGP is it should be a full mesh. So in this case, if you see the if you see the challenge for the R4 to connect to R3, it doesn't have a direct link. So there is a only way to make an IBGP to this guy. To make an IBGP, I have to definitely use a loopback. So I can't do this loopback. So logically, I'm making a connection to this guy. So what if this is a pain? So if every single device I have to go and I have to make a peering with my source loopback, and it has to be done on the neighbor devices. But instead, if I have a quick solution, a better solution to overcome this problem, that is the use of a route reflector. So what route reflector does? So if you look at this, so instead of using the loopback address to peer with my neighbor, so I'm going to say, this is my route reflector client. All these guys, right? From R4, my R2 is a route reflector client, and this R1 is a route reflector client. So what happens here, even though if I'm not making a neighborship with that? So think about this, guys, because see, the whole point of the IBGP is it is based on the split horizon rule. So whatever the R2 is telling this guy, let me use a different color, that's again will stand out better. So whatever this guy R2 is advertising to this guy, this R4 will not advertise this back to R1 because of split horizon rule. So to overcome this problem, I can use two solutions. To overcome the split horizon problem, I can use two solutions here. One is using the, let me erase this. Let me use the, for the split horizon problem, you can use loopback interface, or else you can use route reflector. So you can use two solutions. So we saw that, and so far we are dealing with loopback interfaces to overcome this problem, split horizon problem in BGP. It should be full mesh. So instead, we are doing a route reflector here. So I am making this guy R2 for R4. You are my route reflector client, and you are my route reflector client. And let's see if I can still establish a connection. So when I draw a quick line between this, so these two guys are my route reflectors, and over here I'm making an EBGP connection, and we are going to see using the multi-hop, and without the multi-hop command, do I establish a connection? We'll see this in action. So this is the whole objective of this lab. So we are going to do the IBGP pairing with the route reflector, and along with that, we are establishing a EBGP for the loopback interface. That's something we haven't done that in the last lab. The whole point is, okay, if it is directly connected, I can establish a connection. If it is not directly connected, so how I'm going to overcome the problem, and what is the configuration changes I have to do to establish a connection with my neighbor if he is more than one hop away. So now let's jump into the lab. So I'm on R1 over here, router ID 1.1.1. I give show run section BGP. So I'm going to remove all the BGP config here. R1, let me go and remove the BGP config on R2. Give show run section BGP. So I'm going to remove the BGP config on R3. R4, sorry, R1, no BGP config. On R1, this is actually an R1 guy here. So I have a two console for it. Let me quickly check the config. Show IP interface brief. There's no config, so I got fast Ethernet 0/0/0/1. Okay. So this is 20.0.0.3. So this is an R1, this guy. And R4, this is an R4. Fast Ethernet 0/0 and 0/1. I think the config changed. Let me make this an host name R4. Oh, here's this guy, R4. So, okay, let me see, show CDP neighbors, give show IP interface brief, config, interface range, fast Ethernet 0/0. I'm an R4, so the route rate is 4.4.4, 0/1, shut, show CDP neighbor, CDP neighbor, show CDP. Okay, so I don't have an IP config here. Let me quickly do the IP config. So IP interface brief, exclude unassigned, config interface fast Ethernet 0/0. That's going to R2. I'm going to an IP address 30.0.0.1. Show IP interface brief, include unassigned. So this is 30.0.0.1. So here is 30.0.0.2. So let me copy this. So for this is for 30 network, yeah. So this fast Ethernet 0/0 and this is 30.0.0.1 over here on R2. So I'm going to R2. I'll jump back again to R4, and over here this is 30.0.0.2, and it is subnet mask is /24 255 255 255 0. No shit. Interface fast Ethernet. So now I'm going to configure the link which goes to R1 over there. It's fast Ethernet 0/1, IP address 40.0.0.1, 255, 255, 255 0. No shut. To show CDP neighbors. Okay, I see R1 over there. Fast Ethernet 0/0 is showing us an R2, this guy, and over fast Ethernet 0/1, I can see an R1. So my IP connections seems to be good. Let me check. So IP interface brief, exclude unassigned. Can I ping 30.0.0.1? Can I ping 40.0.0.1? Yeah, I can ping, so my neighborship is good. So I'm going for a BGP config. Just 1 minute, guys. Let me this. Okay. So I'm going to use a route reflector. So first I have to do a BGP. So router BGP1. My neighbor is 2.2.2.2. I have to create a loopback interface. The interface loopback, because we are using the loopback interface for pairing everything. So interface loopback 0, IP address 4.4.4, 255, 255, 255. It's done. So I'm going to BGP config on R4, router BGP1, neighbor 2.2.2, update source. Before that, I have to give an ASN number. So remote AS1, neighbor 2.2.2, update source loopback 0. Okay, we are doing it a route reflector. Sorry for that. So 2.2.2, give a route reflector client. So this connection is going here. I'm doing a route reflector for this guy R2 as well as for R1. RR stands for route reflector. I'm doing route reflector client and the same thing. So I want to make an IBGP neighborship with R1 over here. Neighbor 1.1.1 route remote AS1 neighbor 1.1.1.1 route reflector client 1.1.1 update source loopback 0. Then router BGP router ID, the loopback interface of it, my router ID 4.4.4. Okay, show IP BGP. Show run section BGP. So I made a neighborship with this guy. Okay, to remove this, we are not using. Sorry for that. We are not using the loopback interface to make a neighborship. No neighbor update source loopback 0. Okay, I didn't make a neighborship for that. I gave show IP BGP. You know, guys, why I don't see a neighborship? You guys can ping me in the comment why we cannot do that. If you see that I don't have a route for the loopback interface, so I'm trying to establish an IBGP connection here. It's totally expected for the BGP. And also one more thing I have to check. I'll answer for that why we don't see this, because apparently if you want to see the BGP routes, you should have a routes in the RIB. If I don't have a RIB, I cannot establish a connection, right? I want to make a static route. If I want to go to router 2, 2.2.2, destination 255, 255, 255. My next stop from R4, my next stop is the T001, right? My physical interface, I have to go through the physical interface for it. Same way for my router 1, 1.1.1, all 255 specific /32, and it is 40.0.0.2, the physical interface. So run section BGP config. So I want to redistribute this routes because BGP doesn't know how to reach that. So I have to do redistribute connected. So IP BGP. If you look at this, this is not selected as a valid and best route. Still, show IP route. So I have a static route for router 1, as well as for router 2, and I want to see for router 1 and router 2. Yeah, for router 1 and router 2 I have, but still I don't establish a connection. So we're going to troubleshoot why I cannot establish a connection. Show one section BGP. So I made a neighborship for all this, and I'm redistributing the connected networks. Give the router ID, and I made a route reflector for these two guys. So let's jump back to R2 and see what you can see in the BGP. So IP BGP. BGP is not active here. So no BGP config. Show run section BGP config. router. Before that, I have to do this. So IP interface, brief, exclude, unassigned. So I have a loopback interface. I have an IP communication. That's good. So let me try if I can reach from R2. I can reach 30002. This guy R4 ping 30002. Cool. So I can establish a connection now. Can I ping the loopback 4.4.4 source loopback 0? I cannot. Apparently, I should not see the route for it. PQ show IP route. So I do have route for it. Okay, show run section route. I have a route for R4 over 40.0.0.1 from R2. So I don't want this. So I want to remove this because this is going a longest path from R2. It's going to 40.0.0.1. I don't want that to happen for R4. So I'm going to remove that static route. No IP route 4.4.4. So I want to make a static route for IP route 4.4.4, all 255, and my next hop would be from here. It is 30.0.0.2. 30.0.0.2. Show run section BGP. Okay, we got a static route. We are doing the BGP. So I'm an R2 router BGP1 IBGP BGP router ID this router 2 2.2.2.2 and my neighbor 4.4.4 4.4.4 to this guy router ID 4.4.4 remote AS1 IBGP connection. Redistribute connected, and then to show run section BGP. Redistribute connected. So I made a neighborship with this guy. I don't want to do anything. So only here, this guy is in the middle transit point between R2 and R1. This guy is not advertising this back, and so the whole A is right. So for AS1, so because of the split horizon rules, whatever this guy is advertising, this guy is not going to advertise this back to R1. To overcome this problem, we are running only the route reflector on the transit router on the R4, not on the other routers, without using the loopback interface. So if I give show IP interface brief, exclude unassigned, I see my loopback interface. I configure my loopback, advertise my loopback. So I made a neighborship with this guy 4.4.4. Okay, so now let me go to R4 and see show IP BGP. So if you see now it is changed to wireless and best route. So this is for 4, this is for 30, but still, yeah, I'm not still seeing this 2.2.2 show run section BGP 2.2.2. This is correct. Redistribute connected and jump back to R2. Show run section BGP. Redistribute connected and made a neighborship with this guy. Can I ping 4.4.4? Source loop back 0. I can ping. Let me clear IP BGP. Start soft. So IP BGP. I have valid best route for this, but it's not coming into the routing table of it. Show IP route. I have a route over this too. So run section BGP. Show IP BGP summary. So it is still in idle state. It's not sending any packets. If you see, it still stays down. We have to troubleshoot that first. Section BGP. Back to R4. I made a neighborship for R2 and made it as a route reflector, as well as for I did the same thing for R1. What is the other challenge we have here? One dot one dot one, 2.2.2 redistributed. I have a route ready advertised. I can ping, but still why it's not coming up here? Show IP route. Show IP route BGP. Show IP BGP summary. It's active, but not sending any information. Let me check. Router BGP1, neighbor 2.2.2. Is that should not happen? Update source loopback 0. Loopback 0. If I go to R2, router BGP1. Okay, so from R2, okay, got it. So I am on, now I'm on R2. My neighborship is up. So run section BGP. Show IP BGP summary. Active. So from, so I have to jump back to R4. Okay, got it. Okay, so okay. So from here, I'm trying to establish an IBGP. The problem what we encountered so far. So I missed one thing here. So if you look at R1, I'll show you. You guys will understand this. Show run section BGP. So I'm not using a source loopback here, but the transit point router, it should have a loopback. So I missed that point. So only the peering devices, right? Only the peering device, the transit device should establish a connection over the loopback interface because it doesn't know how to reach here. But for R2 to establish a neighborship with R4, if you see this, we are not making a neighborship with the loopback interface because this we are running the route reflector on the transit point where you have to enable your route reflectors as well as your loop back peering should be there on the transit router. So our transit router here is an R4. Show run section BGP. If you look at this, so I made a neighborship with the 1.1.1 and 2.2.2, and I'm using a source loopback 0, and I'm using route reflector client. So because of that, so I establish a connection to this guy. So run section. BGP. So R1 I haven't configured anything on R1. So in R2, if you see, I haven't configured the loopback interface, but still it works because of the route reflector on the transit device. That is my R4. So if I give show IP BGP, clear IP BGP star soft ping 2.2.2 source loopback 0. I can ping as well as from R2 ping 4.4.4 source loopback 0. I can ping show IP BGP. The valid and best route is for this guy, and 4.4. I want the next hop is 4.4.4. So we'll talk about the next hop. So far now we made a neighborship between R2 and R4. Let's jump back to R1. This guy will establish a connection. Show run section BGP. There's no BGP configuration here. Configure. Show run section BGP. Sorry, show run. Oh, sorry for that. So IP interface brief exclude unassigned. I have assigned an IP address on it. I'm on R1. Yep. Okay, so I'm going for BGP config. What about my routes? Show run include route. So I have a route for R2. That's fine. It's going to 40001. That's good. So I for R4, I'm going to 40001. Okay, got it. So I have a route. So only BGP part I have to do it. So router BGP1 neighbor 4.4.4 remote ES1 IBGP neighbor 2.2.2. Yeah, both this guy R2. We know the router ID. You can find it. Neighbor 2.2.2 remote AES1. What else? Show run section BGP. Router BGP1. Redistribute connected. Okay, I have to give one more thing. Redistribute static. R2. Show run section BGP. You know what's happening here? Redistribute connected will just advertise my loopback interfaces, but I have to advertise my static route as well. Yeah, I forgot that to do for BGP. Redistribute static, and to go do the same thing on R4. Jump back to R4. Show run section BGP. Config router BGP1. Redistribute static. So IPBGP. Here we go. So for R1, for R2, if you guys have observed, let me scroll back this. From R4, I'm on R4 to R2. If you see this, rib is failing for it, right? R stands for, say, rib failure here, the output. Because we haven't redistributed the static route. For the BGP, it doesn't know how to reach there. But still, we have a route in the routing table and it worked. But if you want a route to be in BGP, it should be a valid and best route. That's something we missed over here. Once we did this redistribute static, so now if you see it became the valid and best route. So this is very important. You should always do that. And what are the key values you should look at? I am on R4, the valid and best route, and if it says all zeros, right away when you run any time in your production network, if you show IP BGP, so the all zeros, right? If you see all zeros in your next hop, that's self-originated routes. So if you see this, show IP interface brief, exclude unassigned, and you have this loopback interface on your device. This is locally originated routes. That's very important. So this route is a foreign route coming from the other device, but if you see all zeros, that's the route that's local to the device. And it should be always a valid and best route to reach the destination. For this, if you see this 30.0.0.1, this guy over here is my next hop. That is totally expected. So I'll tell you the next hop scenario when we are talking about the eBGP. That's very important for it. So for now, we establish a connection and it became valid and best route. So what if I jump back to R1 and I see that? Do I see any changes? Show IPBGP. So for R2, it's a valid and best route and it's going through 40.0.0.1. And if you see show run section BGP, so I'm not using a source loop back because this guy, right, due to the split horizon rule, he's blocking this traffic. Let me take a different color that stands out better. Okay. So this guy is advertising the routes to this guy to reach over here, but this guy knows about how to reach here, but because of the split horizon rule, he's not doing that, right? So what we did, as I said, you have to make a neighborship, the three key things. If you actually see this, let's jump back again to this because this is very, very important when you make a neighborship, where to apply the route restrictor, right? Section BGP. So I made a route reflector and I'm using a source loopback only on the transit router and not on the neighbor devices. Only on the transit device you have to do that. And if you see this, the route reflector for R1 and also for R2, I did a route reflector. And if you go back to R2, if you see the BGP config, that's different. Show run section BGP. So key things, you have to redistribute to your connected routes. Also, you have to redistribute static route because BGP is purely an unique cast. It is not like a dynamic routing protocol. So you should tell the BGP how to reach it. So for that, you need either a static route or either you have to do an OSPF as any other protocol. So based on that, I mean the routes, whatever it learned through a different routing protocol, you have to inject those routes to BGP to reach. So now we are using just we are redistributing the connected networks and also we are redistributing the static routes because we are running a static routes between the devices. So that's the whole point of route reflector, where to apply and how we can make a neighborship. So you can also deploy the same thing. You can give a design principles when you're establishing an IBGP. So we come across all the different scenarios because of the split horizon rule. It's happening, and we saw how to do that and which where you have to apply your route reflector is very important. So and this is applicable only for IBGP. So next we are going for an eBGP multi-hop. So for that, let me jump back to R5. So we did this part. So we made an IBGP relationship between these two guys, and as I said, we did a route reflector. So R1 can talk to R2, R1 can reach R4, and R2. Now the split horizon rule has been sorted out because of using the route reflector. Now let's jump back to R5. Show run section BGP. Okay, let's remove this BGP route from this. No router BGP 2. This is on external BGP, right? This is on AS2 if you look at this. And these two guys, R3 and R4, they are on AS1, but it is trying to establish a connection to the external BGP. So now I'm going to remove this route, router BGP 2. Show running section BGP. Show running include route. So I have a route for R3 and R4. Show IP interface brief, exclude unassigned. So I have a loopback. So now let's do a BGP. So here I'm running the eBGP router BGP2, not in the same autonomous system. So I'm making a neighborship with neighbor 3.3.3 remote AS1. Yeah, this is an eBGP. And also I have to jump back. Okay, no, I'll make a pairing with R1 as well because I am on R5. I want to make a pairing for R5. The neighbor 1.1.1 remote AS1. And I have to jump back again to R3. Show run section BGP. I don't have a BGP config on R3. Show IP interface brief, exclude unassigned. I have a loopback. I have an IP connectivity. Good. So let me try for 50002. Let me give show IPR. I can see 50002. That's expected. So I want to do only BGP. If I do ping 5.5.5.5, I can ping because I have a static route. Include route 5.5.5 and go to this thing. Okay, I got a route. That's good. So only the BGP part we have to do it here. Show run section BGP config router BGP. This is on BGP 1, right? My remote autonomous system is 2. Neighbor 5.5.5. Remote is 2. And let's jump back to R1 here. Router ID 1. Show run section BGP. Configure router BGP 1. And my neighbor would be 5.5.5. Remote AS 2. Yeah. R5. PQ show IP BGP. Show IP BGP. I don't see the neighborship for it. Show IP BGP. I don't see the neighborship. Show run section BGP. If I go to R5, I'm an R5 router BGP 2. Neighbor 3.3.3 eBGP multi-hop. As I said, I can give the hop count of 2 or I can give a hop count of 5. It depends on how many hops away. This is 2 hops away. So for neighbor 1.1.1 eBGP multi-hop of 5. So run section BGP. So I did a eBGP multi-hop on R5. You show IP BGP. Still, I didn't establish a connection. We go to R3. Neighbor 5.5.5.5. eBGP multi-hop of 5. Clear IP BGP star soft. Show IP BGP. Okay, you know why? I know the answer. Why? Router BGP 1 redistribute connected, redistribute static. We go to R5 config router BGP 2 redistribute connected, redistribute static. Go to R1, run section BGP. Router BGP 1 neighbor 5.5.5 update source loopback 0 neighbor 5.5.5.5 BGP multi-hop 5 so IPBGP. So IPBGP summary, still my neighborship is not happening for R5. So run section BGP. I redistributed, show IP route. I have a static route for R5, no? Show run include route. Okay. So I don't have a route for the loopback. I'm going to create a route from R1 to R5. 255, 255. So from R1, I want to go through the physical link 60.0.0.2. Show IPBGP summary. So if I go back to R5, so run section route. So I have a route for router 4, router 3, but for this guy, I have a route over the 50.0.0.1. Can I ping from R5 to R3? I can ping, but I didn't do a source loopback on R5. If you look at this config, I haven't made a neighborship with the loopback router BGP 2. So two neighbors, one is from R5 1.1.1.1 update source loopback 0, and the neighbor 3 3.3.3.3 update source loopback 0. If you look at this, because of that, there's no neighborship. Show IP BGP summary. If you see this, I'm receiving 11 prefixes. So what are the key values you should see here? I'm receiving 11 prefixes from this neighbor 1.1.1 and 7 prefixes from this guy. 7 networks, right? All the 7 networks from this. Now I established a connection. So for the EBGP neighborship, what are the key things you should know about show run section BGP? So the criteria number one, the BGP, if it has to be in the valid and best route, show IP BGP. If it should be always should not be RIP failure routes. It should be always your valid and best route. So for the valid and best route for from R5, the valid and best route for R3, yeah, it's 50.0.0.1 because we have a static route for it. So I have reachability. And also I should, the very first command you should run always is show IPBGP summary. So your state should be actually an established state, right? So if you are not establishing connection, if it is still an active state, so your neighborship will never happen. So only after this state, we have seen this, we'll see this open messages, and we have seen, what are the key values we have seen. Now we will do a capture and we'll see the, information, what it is going on between the EBGP neighborship. So here now we established the EBGP. As I said, the condition, if you see, show run, let me do a trace route, trace route, trace route 3.3.3. I have to go one more thing. I failed to do that. I have to do a trace route from my source 5.5.5. This is, when you're just doing a trace route for 3.3.3, it's going to use your exit interface. So here it will use 50.0.0.2. It always happens. So source loopback 0. So it is going through 50.0.0.1 to reach there, and I have a route. So EBGP is established. So now the other thing here, it'll draw a line for this guy, right? For this guy, we establish an EBGP with this guy. Yeah, and I'll take a different color, makes a standout. So here we are running IBGP. Let me grab my pen. So here we are running IBGP. Here we are running EBGP. Using the multi-hop, you are establishing a neighborship over the loopback interface from and to the loopback interface, right? So until this point, you have an EBGP neighborship. But for this guy, if he is trying to reach to R4, your next stop should be, what happens there. Let me show you the routing table of it. I'm on R5. It gives show IP BGP. If I check for R2, what is that it's showing here? It's a 1.1.1. My next stop is this guy. So if from R5, yeah, from R5, if I want to reach R4, my next stop is 50.0.0.1. This is fine. We have a static route. So we'll take this scenario. So it is telling for to R2, from R5 to R2, my next stop it is showing 1.1.1.1, right? But how this guy R5 can reach 1.1.1.1? Does he has an peering with this guy? Show run section BGP. So I made a neighborship only for 1 and 3 and not for this guy, R4. What if I try to do that? For this guy, for AS2, for AS1 is a remote network, right? Sorry, remote autonomous number system from the BGP standpoint. Yeah. Section BGP, config, router BGP 2. So I'll make a neighborship for R4, for R4, R4, remote AS1, for R4, R4, update source loopback 0. I have to go to R4, this guy over here, show run section BGP. So I want to make a neighborship for R5. Router BGP 1, neighbor 5.5.5, remote AS2. Yeah, this AS is 2 for R5. Neighbor 5.5.5, update source loopback 0. Then the very first thing I have to check is my routing table for that, include route. So I don't have a route for R5. IP route 5.5.5, all to 55. My next hop would be from R4. For my next hop would be 40.0.0.2, right? Okay, look at this. 41, 2. 40.0.0.1. Oh, sorry. 40.0.0.2 itself. So it is 40.0.0.2. My next hop from this guy, 40.0.0.0 is my next hop. So from R5, how do I have a route for it? So IP BGP summary. Still for R4, I'm not establishing connection. So run include route. So for R4, I have a route 50.0.0.1, and the transit point for R4 and for from R5, the transit point is R1. For R4, the transit point is R1. So this guy should know about R4 and R5, right? So I have to jump into R4, R1, sorry, here. So run section BGP. So I made a neighborship with R4 and R5. But for R4, okay, we are using route reflector, IPGP, so I didn't use that. What about my routes? Show run include route. So for R5, I'm going to 60.0.0.2 right over here. And for R4, I have a route for 40.0.0.1. So let me go back here. Show run section BGP. So I'm trying to establish for R4. I didn't do a eBGP multi-hop. It's more than one hop from me. It should be directly connected. That's a condition. Router BGP 2, neighbor 4.4.4, eBGP multi-hop 5. If we go back to R4, So run section BGP. So this is a remote autonomous number system. I want to establish a connection. It's not a directly connected. I have to use some eBGP multi-hop because it has a multi-hop to reach it, not on one hop I can reach. It should be directly connected. Same condition apply everywhere. So router BGP1, neighbor 5.5.5, eBGP multi-hop 5. So if you'll see this, once I give this command, my BGP came up. Show IP BGP. So from this guy, R5, right? Yeah, I got a neighborship now. So your eBGP multi-hop is very, very important when you establish a eBGP, and if it is not directly connected, you're making a neighborship with a loopback interface or anything, right? So say right from here, this guy is not directly connected. I have to go through this. So I made it eBGP multi-hop. I gave a hop count of 5. So from here, 1, from loopback 1, then from physical interface 2, 3, 4. It's 4 hop away. So eBGP multi-hop is very, very important for your neighborship. And we're talking about the next hop self. So if I give show IPBGP. So for 4.4.4.4, my next hop is 50.0.0.1. Where is it? This guy. It's showing here. Oh, sorry for that. I mean, we are looking for a route for 4. Here, the valid and best route is 50.0.0.1. Okay, it's showing 50.0.0.1. To run section BGP. So for this 4 network, is it? Well, let me give a trace route. Where actually it's going in the trace route. So I'm trying to find, yeah, how I'm going to R4. Oh, where is my static route from R4 to R5 to R4? So run include route. So for this guy, okay, I gave 50.0.0.1. Oh, okay. It should be actually 60.0.0.1, right? So if you look at this link, okay, so I gave this and it's going through that. You give a trace route. So this is how you have to check your routing tables and your routes to ensure that how exactly your transit point is something you have to decide. You can design an update based on that. Trace route source loopback 0. I'm trying to find from R5 how I'm reaching R4 based on the static route. I want to see you know the routers it is traversing through to reach 4.4.4. Okay, since I gave 50.0.0.1, thus it takes the static route and it's going there right over here. From here it went here, then it went to 10.0.0.1. If you see, this is going to a different AS number, right? AS1, and then again it's coming back 30.0.0.2 and it's reaching here. So this is taking this path. So if you want to do your traffic re-engineering, if you want a shortest path, if you look at this, this is the longest path. If you want to do a traffic engineering, you can actually change your route to this guy. From R5 is the show run section BGP IP BGP. So I want to see for R4 50.0.0.1. So this is for R4. This is the valid and best route. 50001. So over here, if I come back to R4, show IP BGP, and if I see for R5, valid best route is I'm going to 40.0.0.2. I'm going to change this. I want the shortest A's here. I mean, we are using just A's 1 and 2. I want to take shortest path. So this is 4 hops away. Let's see if I can manipulate the route. Show run section BGP. Show run include route config 4.4.4. Let me remove this route. Instead, I'll give 4.4.4. I'll give 63001. So IPBGP. So for the 4 network, it is going to 60001. If you see here, I made the shortest path here using the static route. So if I give trace route, so 4.4.4. From R5, I'm trying to find a hop what it takes now. It's coming to this 60001. Come on, okay. It's coming here and over here. If you look the trace route output, where is this trace route? Okay. So if you see this, it took 3 hops to reach there, but here in just 2 hops, I can reach to this guy. And this guy, he is on AS1, it is telling that. Now let's take a packet capture and see. So a quick recap what we did, and I'm telling you guys this. If you understand this EBGP and IBGP and the route reflectors, how to establish this connection. See, your core fundamental of establishing your BGP, you are playing with your attributes, you are doing your re-engineering. Believe me, the IBGP and EBGP neighborship is a solid foundation for your BGP. If you guys are not doing this, you cannot play around with your attributes. So I have seen this in many scenarios. Even I had, struggled a lot when I'm doing this labbing it, and when I did a multiple topologies. So I have gone through a lot of problems. So every single detail is very, very important in your BGP. It is not like OSPF or EAGRP, you're just using the network commands you can redistribute and your neighborship will happen. No, BGP is a bit more complex protocol, and you know that it's very toughest protocol when compared to your EAGRP and OSPF because you have a lot more attributes. But believe me, again, I'm telling, if you're fundamentally very good with this lab, you can build other attributes because I'll tell you, you play around with your multiple attributes. What if you don't know how exactly the IBGP and EBGP works, and what is the use of doing all these attributes? I would say a specific thing, not the use of. I mean, you will be lost sometimes when you're troubleshooting your BGP. So the core fundamental is we have to go through the same troubleshooting procedures, and you should know what is the use of next hop. We have seen how we can manipulate the next hop re-engineering, how you can do and you can manipulate your routes in BGP. So before that, the very first thing is how you're making a neighborship. So from R4 to R2, it is an IBGP, and R4 to R1, it is an IBGP. And as I said, due to the split horizon rule, this route is not advertised in IBGP. That's the nature of IBGP. So to overcome this problem, we can use either the source loopback. Sorry, we can use we can use loopback interfaces to make a neighborship, because it has to be directly connected. That's practically not possible, because a network that is on on R1, it is not directly connected to this guy. Only have I have one cable running to R1. I cannot run multiple cables to it. That's not a feasible solution. So to overcome this problem, I am making a logical neighborship. So for that, you have to use your BGP router ID along with your loopback interfaces. You are making your peering with the loopback. And as I said, where it is exactly use the route reflector, you just imagine I got R2 and R1. What if I this is a hub, SD-WAN hub, and you got 120 sites. You have 500 sites. The principle is same. So all you are going to do is you are making an BGP neighborship using the loopback interface only on the hub devices and not on the spoke. All I'm going to do is I'm using the route reflector. So the route reflector, what happens? It reflects the routes, what it learned from R1 to R2, and what it learned from R2, it reflects back to R1. So it generally is the throwing out the network to all the neighbors whomsoever it's configured. So this route reflector attributes very, very, this is the best practice. And I mean, I would not say the best practice, the very feasible solution for the SD-WAN problem for IBGPs. You have, 50 sites in your data center, and if you want to make a neighborship with every device, just think about that. You have to use a so you have to make a neighborship with a loopback. That's very, very, it's very time consumption process, and it's not a feasible solution. The smart way of doing it is you can use your route reflector. So where you have to use the route reflector, this is a scenario as I told you, like your SD-WAN with multiple spoke devices, you can use route reflectors. And coming back to the EBGP, as I said, EBGP condition is it should be directly connected. There is a one way to disable it. Disable directly connected criteria. That is not a feasible solution. You know what? Anybody can make a neighborship with your device. That is a biggest security problem with that. So it is always suggested, and the best way of doing it is using the EBGP multi-hop command. So using that, you can make a neighborship with your devices. And if you see this, your next hop is very, very important. You have to check your, first when you establish your connection, you have to give show IP BGP summary command to check, is it, do I really have a neighborship with that guy? Show IP BGP summary. This is the very first command before you run your IBGP summary. Sorry, your IBGP. Your IBGP will show you your BGP routing table. This is actually showing your TCP connection, and it is completely in established state. I'm receiving all the PFX for receiving the routes. So regardless of the number of networks you're running on a router. So how you're going to see that? I mean, do I see all the routes that's been thrown out from R4? Uh, yeah, from here, if you say this R1, so I'm throwing out, the R1 is throwing out 11 network informations to this guy R5. So I receive all the prefixes? If you're missing something, you can go check your advertisement. Yeah. So for R3, I'm receiving 7 prefixes. For R4, I'm receiving 11 prefixes. Once this is done, you have to give this command. This is actually very important. So the key things you have to see here is my next hop is properly configured. I'm going to the shortest path. Then it has to be valid and best path, and it should not be RIP failure. RIP failure means that you do not have that route in your routing table. As I told you, so IPBGP has its own routing table. So IP route BGP. So if you see all this is all this networks it's learned through BGP. So if a valid and best route has to be here, then you should have that route in your routing table. So when I say routing table, this is a generic routing table, a common routing table. So this routing table is only for BGP. So always you should use show IP BGP, and you have to ensure that your next hop value is properly, you have a proper next hop to reach it. Yep, that's very important. So it has to take the shortest path. It is not necessarily has to go through R3, R2 and reach R4. Instead from R5 it is just three hop away. So now let's do a packet capture and see the key details what we can see there. For that, let me go and shut down this port. Interface fast Ethernet 0 slash, sorry, show IP interface brief, exclude unassigned. So let me go to router BGP, sorry, interface range fast Ethernet 1/4 to 5 1/4 hyphen 5 shut. So I turned off this port, it's admin down. So let's go back to the capture. I have to do a capture before doing this. It's fine. So I'm capturing the traffic between R4 and R5. I want to see some EBGP packets. So it's sending keep alive packets. Are you alive? It's coming from R4 to R5, and R4 is doing a retransmission to R5. It couldn't find it. Continuously doing a retransmission. Now let's go back and turn on, and let's see what's. So it keeps sending keep alive. Now it's R1 sending back. Show IP BGP. You see the keep alive. Show IP. Show IP BGP summary. So all the neighbors, right? Sending keep alive, and you see now R1 is sending a retransmission, and 4 is sending back a retransmission to R5. So with the we know that we discuss this a lot. So you guys are very familiar. I'm very confident on that. The R4 is doing a retransmission to R5. Everything's doing to a retransmission to R5. So that proves that R5 is down, right? R5 is down. It's not responding back. We turned off the port. So let's see what if I turn on the ports. Show IP interface brief, exclude unassigned, config. If you look at this, my loopback is up, but still my physical interface is not up. Can see multiple notification message. The hold on timer expired. It's keep trying to establish a connection, but send a notification. I cannot establish a connection with you anymore because the hold timer expired. So if we go back to this, you can also see the same output here, but you don't see the retransmission of the detail. So if you look at this from one device, I can see the neighborship of all the devices, right? So logging. Do show logging. Come on, do show logging. Let's see this. Let's do a debug. Debug IP BGP. Debug IP BGP. Events. No route to peer. No route to peer. No route to peer. R1 is trying to send us in. Okay, we know this, so we'll go back and see what is the other information we'll see when I do that. Show IP interface prefix load unassigned config interface range. Let me do you all stop the debug config interface range fast ethernet 1/4 2 5 hyphen 5. Oh shit. Neighbor status up. What else I can see here? The neighborship is up. Can see the R packets, SYN packet. So now if you see the three-way handshake happened, right? Since in ACK between R5 and R4. So it's an open message. So it is telling that my A's number is 2, this guy, or fine. The open message from source 4.4.4 BGP identifier. So that's why the BGP route rate is very important. So it's coming from A's 1, right? The 5, so if you see the A's number is 2. In the update message, what should you see? You should see your NLRI information, network layer reachability information. So I am on R5. See, it learned about R4, R3, EBGP 60, 50, its own router ID with the subnet mask values. So I learned all this, right? So I know how to reach all this network. So if you're doing a troubleshooting and if you are not finding any particular network over here, it's either a problem with that device, the remote device, it's not properly advertised. Yeah. If you can reach the other networks, example here in 3 network, if you're missing something in your NLRI, so that's something in the 3 network, you have to look into it. Your IBGP, your network config, your routes. So now if you see three-way handshake happening, right? Because the bit between these two guys, R5, R4, because we have an EBGP neighborship only with R4 and R5. So from this guy, it's showing that. So when you're troubleshooting, the very important parameter you have to look into is your NLRI informations. How you reach your foreign networks. If you know the NLRI information, network layer reachability information, only then you can reach it. But to reach it, you should establish a successful three-way handshake, right? Conversation filter, TCP. See, your three-way handshake is successful between these two guys. You're making a EBGP neighborship. We have seen the A's number. So everything line by line you can check. And if something missing, you can check what has to be done and you can troubleshoot. This will give you a lot more detail, right? So the whole objective of this lab, and I believe that everybody, feel worth about it because we discussed a lot here. We discussed about route reflector, we discussed about EBGP neighborship, and we discussed about the use of next hop self, where how you can change your next hop based on your routing, and we have gone through how to check the key values you have to check when you're troubleshooting it. So now if you see my neighborship is up and running for all this networks. The same network in the open messages you should see, right? I mean, the update messages in the NLRI, what is the same, neighborship, whatever you have here, you should see the neighborship, right? This is coming from R5 source. So this is how, if you have your perfect neighborship, this is how you can do it. You can definitely play around this in this lab. This will definitely give you, a complete insight, and you can master your BGP skills for sure if you do this. And also we discussed about the AS path, we made a neighborship between IBGP and EBGP. Then we did an AS path, sorry, not AS path preference. We did a local preference, and the local preference is again it is used only for IBGP, as I told you. Um, the best practice of local preference, as I said, if this is a transit point again for R2 and R1, if it's a transit point for R2 and R1, so if you have the highest local preferences, you're throwing the highest local preference out to R2 and R1. So this guy will not take this R5, R3, and R2. Instead, he will take R4 to reach R2 if it is a core device and if you have a redundant device. So example, if you see this, this is your core switch primary and secondary example. Primary and this is your secondary. And if you have the highest local preference, always all the devices in your network, right? So it has to go through this to reach out to any foreign network, because your core switch primary switch should have the highest local preference, and this guy should have the least local preference compared to your primary core switch. If it is going to your ISP like this, yeah. So your transit path, always from any router, your transit path to be this guy. So if that should happen, then you should have the highest local preference here. And through IBGP, your highest local preference, the devices through your neighborship, you can throw out your highest local preference. So all these devices, it will come to you to reach any other device. That's the best practice, right? Because there's a core switch where all your VLANs hanging off on this device, and it has to go to this device, and if this device fails, only then this device has to take a role of primary, and it should be a transit device. Okay, fine. So that's it really about BGP, the best practices, and I would suggest everybody to do this lab. Now let me stop this recording.